See, but the actual mass is actually not that much. It is actually 544.9, right? So 544.9 means that if it would contains only carbon and hydrogen, the expected mass would have been how much? I mean, these are the possibilities. Expected mass 543.9, but we are getting this one. So it is quite, sorry, you can see here for 442, if we are trying carbon 30, hydrogen 62, if we are trying carbon 5, hydrogen 12, 72, see, on and on. But for this, we are not getting any information. Only information that we can get is that nominal mass of 545, and then this one as well. So actually, this is because of that isotopic peaks that is coming. Because the pattern, you already know that this pattern is actually, if you look at the intensity of these, so I'm considering the intensity, if that is only carbon, hydrogen, oxygen, so for that carbon is how much? Carbon, hydrogen and oxygen. Where is that list of mass? Here it is. Carbon is contributing 0.0000, hydrogen is 0.08, oxygen is 0.999. So if you multiply this, it would not be that much. So if you sum up this, you can see here that oxygen that is getting this 0.49. So after adding all these, you are getting this one 0.999, right? But along with this, you also get this 0.999 from the so if this combination is not possible with the carbon and hydrogen, this combination is also not. Oxygen should be there. And along with oxygen, there should be any halogen, because if we are not putting the halogen, we are not getting this combination. If we are only putting the carbon, hydrogen, and oxygen, the only possibility is the only mass that can reach is that 544.8. But if you are putting the halogen as well and reducing the number of hydrogen, and then you are getting this much, which is the case. So it gives this fractional mass gives you a clue, informations about the molecular and peak and as well as the molecular formula. So you can just make a practice on this. Just try different. This is called the elemental composition. You are using the various combination of the carbon and hydrogen. Try to reach the molecular ion peaks, because we only get the molecular ion peak or the M by Z in the mass spectrum. We try to assume various things. We try to find out the molecular formula by assuming. If we are assuming only carbon and hydrogen, what combination would be possible for this peak? And then if we are trying carbon, hydrogen, and oxygen as well, then what will be the possible nearby mass? The nearby mass is 548.8, which is far more. But this mass is coming very near, which is actually the case, because this is iodine. So you can try various heteroatom as well to reach the overall combination. This is elemental composition. Now, the same slide, as I said, this has been repeated again and again throughout, so we have to ignore this one. Now, here is an interesting thing coming for you, that how you will be able to calculate the whether, because we don't know about our compounds and we want to have a clever guess about how many rings and the double bonds would be in our compounds. So what we can do for that? We can use this formula, this empirical formula that can gives information about those that how many rings or double bond they can be possible in our compounds. So here is the general formula: x minus 1 half of y and plus 1 half of z plus 1. What is this y? Y is the hydrogen, x is the carbon, y is hydrogen, and z is nitrogen. right? So you can apply this formula to calculate that how many rings or double bonds are there. I mean, this is another way, this is called the formula for the degree of unsaturation. Unsaturation might be because of the rings or because of the double bond. So you can do this just by putting various values. For instance, I am calculating for this one. I have this molecular formula, right? But I don't know that how many double bond are the rings are there in this formula on this structure. So how can I do that? Just putting the how many carbons are there? The X value is 6, right? And what about the Y value? Y value is hydrogen is 12, but so 1/2 of 12 means 6, right? This is Y value is 12. So it means that 1/2 of 12 is 6 plus 1. So if by doing that you get 1, it means that this particular okay, so it means that in this particular formula, carbon 6 and hydrogen 12, we have only one degree of unsaturation. That might be, so you can see the cyclohexane is a structure. In cyclohexane, we have only one ring. What about hexane? C6H14. So if you are putting the value C6, carbon is 6, hydrogen is 14, and 1/2 of 14 is 7, and plus 1 you are getting 0. It means that this compound would contains no double bond, no ring, and same is the so is the case. It has no double bond, neither it contains a double bond nor it contains a ring. What about benzene? Benzene usually contains 3 double bond and 1 ring. So the carbon value is 6 minus hydrogen is how much? 6, and 1/2 of 6 is 3. So 6 minus 3 plus 1, and we are getting 4. What does it mean? Benzene contains 1 ring, right? And 3 double bond. So it's very easy. You can calculate the degree of unsaturation in any molecule by having the molecular formula. The same slide has been repeated, so I think we should not focus on that. Nitrogen rule. Now this is very, very, very much interesting. You know, uh, you have the elemental composition. You already know about those. So here we see that two things you should consider. One thing is that your m by z value. Just look at the m by z value, and the other thing is the valency, right? So if your valency is even and your atomic weight is also even, would also be even. This is the case in most of the cases. For instance, if we are consider the carbon, for carbon the atomic weight is 12 and its valency is also 4, which is even. What about hydrogen? The atomic weight is odd as well as the valency. Odd, odd, even, even. What about oxygen? Atomic weight is 16, which is even, and so is the valency, even, even. Similarly, for fluorine, atomic weight is odd, and same is the valency, -1, 1, odd. Chlorine, for both of the isotopes of the chlorine, you see they are odd, and same their valency. Sulfur, odd, even, even. There is only special case of the nitrogen where the m by z, I mean the atomic weight is even, but the valency is odd. This is a special case of nitrogen. Atomic weight even, valency odd. And this could be the basis for the identification of nitrogen in a molecule. If we are dealing with a molecule and we want to find out whether that particular compound contains nitrogen or not, The only thing we can do is just making this basis, because nitrogen has even atomic mass and odd valency. So let me explain in the other video.